How's it going, everybody? Mr. Dickin here. In this video, we're going to be discussing solving systems of linear equations using one of two methods, substitution or elimination. Now, systems of linear equations is when you have two linear equations, aka two lines. So if I were to think of this graphically, I'd have one line and then a second line. The solution to the system is going to be the point at which they intersect. So we can find this easily if we're actually graphing these, but sometimes we might not be given a graph, right? So that's when we have to use algebraic methods in order to do this. So we're going to use substitution and elimination to find our solution. Within these systems, there should be one single combination of x and y values that works for not one, but both of the equations present. This first equation has infinitely many x and y pairs. That would make this equation true. Same holds for the second equation. Infinitely many, that would make the second equation true. But there might be one combination of x's and y's that works for both, and our goal is to find that. All right, so let's get into it. The first problem, we have 5x minus 4y equals negative 18. 2x plus 5y equals positive 6. So we're going to be solving here with elimination, and our goal is to cancel out or eliminate one of the two variables. So we either want to eliminate the x's or eliminate the y's. Now the way that we would eliminate these is by having the same coefficient but opposite values. So for instance, here I see a positive 5x. The way that I would get rid of a 5x would be with a negative 5x down here. Or here I see a negative 4y. The way I could cancel that out or eliminate it is with a positive 4y. I'm not seeing that, which means I might have to change one or both of these equations so that I can do it. I'm noticing right away the y's have opposite signs. I've got one positive, one negative. So I'm going to go ahead and focus my attention on canceling out the y values. So I'm seeing we have a 4 and a 5. I need to figure out what number does 4 go into that 5 also goes into, and that number would be 20. So if I could find a way to change that top equation instead of a negative 4y into a negative 20y, and then the bottom equation instead of a 5y into a positive 20y, we could get some pretty good cancellations going on. Well, in order to turn a negative 4 into a negative 20, I would just need to multiply everything in that first equation by 5. And that's perfectly legal as long as I'm doing it to every single piece. So this would become 25x, right? 5 times 5x minus 20y equals, holy smokes, 5 times 18 would be negative 90. Same thing for the second one. I want to figure out a way. How can I change a 5y into a 20y? I want this 5y to be a 20y. I'll multiply everything by 4. That gives me 8x, 20y equals 24. So now what's going to happen is if I add straight down, some of our values, hopefully, should cancel out if we did this correctly. So we're going to be adding straight down here. 25 plus 8, those are both x's, the like terms, so that would be 33x. The y's cancel. That's exactly what we wanted, right? They're eliminating. And then we have negative 90 plus 24. Well, that would be negative 66. Well, now to solve this thing, to get x by itself, just divide both sides by the coefficient, in this case 33. We're going to get x equals, it would be negative 2. But I'm not done. I know my x value, I need my y value. So I'm going to take this negative 2 for x, and I'm going to throw it into either one of these two equations. It does not matter which one I choose. They're both going to be perfectly valid. This one has fewer negatives and smaller numbers, so I'm going to go ahead and use 2x plus 5y equals 6 to plug this in. So 2x plus 5y equals 6. But remember, we just figured out that x was negative 2. So 2 times negative 2 plus 5y equals 6. All right, so let's solve. That would be negative 4 plus 5y equals 6. Move the 4 to the other side, 5y equals 10. Divide out the coefficient, y equals 2. So I know my x, I know my y, I now have the coordinates at which these two lines intersect. That would be negative 2, the x value, comma, 2. And we're done. So that is elimination. Let's move on now to a substitution example. And just like always, if you guys need to pause the video to write this down, then pause it and write it down. Substitution is always going to be your choice, your method of choice, if you ever see a variable that's been isolated. So y equals stuff or x equals stuff. No coefficients over here, nothing being added, subtracted afterwards, just a plain old y. So what this gives me the freedom to do is make the claim that y is equivalent to x plus 11. So using that logic, wherever I see a y, I can replace it with, you guessed it, x plus 11. So let's go ahead and do that. We're going to have 5x. Holy smokes, that's not what I wanted. We're going to have 5x plus 2 times y, but remember, instead of using y, we're going to call it x plus 11 because y is equal to x plus 11. And that's going to equal negative 20. So now we'll simplify this. 5x plus, got some distribution, 2x and then 22. So 2x plus 22 equals negative 20. I've got some like terms here, a 5 and a 2. So that would be 7x. And we want that 22 to the other side. So we'd subtract that over. Negative 20 minus 22, that's going to give me negative 42. And we would divide out the 7 to get x equals negative 6. All right. Now, just like before, we know x, we know one variable, we need the other one. Well, fortunately, with substitution, if one of your equations is already solved for one variable, one of the variables is already isolated, finding that second one's going to be super easy. Because I know x is negative 6, I just plug in negative 6 for x there. So we're going to go y equals negative 6 in place of x plus 11, y equals 5. So final answer, negative 6, comma 5. Not too shabby, right? All right, last and final one. We've got positive 3x minus 5y equals negative 9. Negative 6x plus 10y equals 16. Right now, this is already set up perfectly to use elimination. Elimination is going to be your method of choice if everything is lined up. You have x's over x's, y's over y's, equal signs lined up, and constant numbers, plain old numbers over plain old numbers. I'm looking for coefficients to match. 3 is not the same as 6, but I could easily turn a 3 into a 6. Maybe the y's will be easier. 5 and 10, I could easily turn a 5 into a 10, though. So here's what I'm thinking. Let's multiply everything from that top equation by 2, so that way we'll get the x's can cancel out. So I'm going to kind of plagiarize that first equation. And then the second equation, if I multiplied everything by 2, would be 6x minus 10y equals, 2 times negative 9 was negative 18. And again, I'm just doing this distribution there. All right, so let's add those up. So the x's are going to cancel. The y's are going to cancel. Oh boy. So I'm left with nothing on the left-hand side of the equal sign. On the right-hand side, that'd give me negative 2. Well, there's no more variables. And 0 equals 2. That's clearly not a true statement. So this would be no solution. There's no solution to this system of linear equations. That means, graphically speaking, we've got parallel lines. They would never intersect each other. Another case that you might see is when you have two lines, when graphed, one is entirely on top of the other. In that case, you'd have infinitely many solutions, and that would occur if you see everything canceling each other out. So when you try to do your elimination, the two equations look the exact same. All right, that's it. That's all, folks. You know the drill. If you have any questions, please let me know. Good luck. Have fun. Be safe. Roll Tide.